Number 5. The Celestial Sphere. In the 4th century, a Greek philosopher by the name of Plato sent out a challenge for all Greek astronomers by the assumption of what uniform and orderly motions can the apparent motions of the planets be accounted for. Plato's challenge got a lot of people thinking, and one such person went by the name of Eudoxus of Cnidus, and his solution? Why not put a bunch of spheres around the Earth? The way Eudoxus planned to carry this out was to have a spherical construct surrounding the Earth, and on the outermost sphere were stars manually stuck to it. So with Eudoxus' plan, he has 27 concentric spherical objects on the inside. In his model, the Moon had 3 spheres, the Sun had 3, and each of the 5 visible planets, including Mercury, Venus, Mars, Jupiter, and Saturn, had 4 spheres. The celestial sphere was thought to have been made up of ether, a mysterious element that could not be seen or felt. Research shows that many ancient civilizations may have assumed the literal truth of stars being attached to a floating sphere around space, but it's unknown how many believed this. In fact, it's unknown whether Eudoxus himself believed in the celestial sphere or if it was merely a mathematical model for him to use. It is reasonably clear, however, that Aristotle saw the homocentric spheres of Eudoxus as real objects. As great as the celestial sphere is for explaining things, we know it's not real, and in 1577, Tycho Brahe saw evidence of just that. Because the celestial sphere is a physical structure with stars stuck to it, it would have had to be solid and impenetrable, right? Well, Brahe, who is known for his exceptional observational abilities, was following a comet whose celestial trajectory would have had to traverse the supposedly hard, impenetrable, and crystalline spheres, thus undermining the belief in any system of celestial spheres.
Number 4. Ancient Ether. In 360 BC, Plato wrote his book, Timaeus. In this book, Plato talks about the classical system of 4 elements: fire, water, earth, and wind. However, he also mentions that there is the most translucent kind, which is called by the name of ether. Aristotle, who had been Plato's student at the Academia, agreed on this point with his former mentor. However, he called it the first element. He noted that the 4 terrestrial classical elements were subject to change and moved linearly. The first element, however, located in celestial regions and heavenly bodies, moved circularly, and had none of the qualities the terrestrial classical elements had. It was neither hot nor cold. It was neither wet nor dry. With this addition, the system of elements was extended to 5, and later commentators started referring to the new first one as the 5th, and called it ether. In Greek mythology, it was thought to be the pure essence that the gods breathed, filling the space where they lived, whereas air was breathed by mortals. These 5 elements are sometimes associated with the 5 Platonic solids. Plato wrote about them in his dialogue. He associated each of the 4 classical elements, earth, air, water, and fire, with a regular solid. Earth was associated with cube. These clumsy little solids caused dirt to crumble and break when picked up. Air was associated with the octahedron. Its minuscule components are so smooth that one can barely feel it. Water was the icosahedron. It flows out of one's hand when picked up, as if made by tiny little balls. Fire was the tetrahedron. The heat of fire feels sharp and stabby, like little tetrahedra. The 5th Platonic solid was associated with the dodecahedron. This was ether. Plato obscurely remarks, the god used for arranging the constellations on the whole heaven. Isaac Newton suggests the existence of an ether in the 3rd book of Optics in 1718.
Doth not this ethereal medium in passing out of water, glass, crystal, and other compact and dense bodies in empty spaces, grow denser and denser by degrees, and by that means refract the rays of light not in a point, but by bending them gradually in curved lines? Is not this medium much rarer with the dense bodies of the sun, stars, planets, and comets, than in the empty celestial space between them, and in passing from them to great distances, doth it not grow denser and denser perpetually, and thereby cause the gravity of those great bodies towards one another, and their parts towards the bodies, every body endeavoring to go from the denser parts of the medium toward the rarer?
Experiments often contradicted the theory of the ether, but by the 1700s it had become so widespread that its existence was assumed to be a given. In the 19th century, luminiferous ether, meaning light-bearing ether, was a theorized medium for the propagation of light. How was it debunked? In traditional scientific fashion, the notion of a luminiferous ether was only gradually phased out as more sophisticated theories came into play. Experiments in the diffraction and refraction of light had long rendered traditional models of the ether outdated. The theory still exists in various forms. Many have argued that modern scientists simply use terms like fields and fabric in place of the taboo term.
Number 3. The expanding Earth theory. The expanding Earth theory is one that states that the position and relative movement of the continents is at least partially due to the volume of the Earth increasing, and conversely, global cooling was a hypothesis that various features could be explained by Earth contracting. Long story short, Earth gets bigger, things spread apart. Earth gets smaller, things come together. But the real question here is, how does the Earth do it? There are 3 forms of the expanding Earth hypothesis, and yes, it is a hypothesis. The first form of the hypothesis suggests that while the Earth is expanding, its mass stays the same. The second form offers that Earth has gained mass while it's expanding. And the third suggests that the universal gravitational constant, or UGC, has decreased over time so as not to affect gravity at the surface of the Earth. Let's take a look at the first form. In 1834, during the second voyage of the HMS Beagle, Charles Darwin investigated stepped plains featuring raised beaches in Patagonia. Upon inspecting the beaches, Darwin hypothesized that uplift at this continental scale required the gradual expansion of some central mass of the Earth, acting by intervals on the outer crust, with the elevations being so concentric with form of globe, or certainly near so. Which basically means something super big, conforming to the shape of the Earth, had to push up all at once, in multiple intervals. And in 1835, Darwin extended this concept to include the Andes Mountains as part of a curved enlargement of the Earth's crust due to the action of one connected force. In 1889 and 1909, Italian geologist Roberto Mantovani published a hypothesis of an expanding Earth and continental drift. He assumed that a closed continent covered the entire surface of a much smaller Earth and broke apart due to volcanic activity. In order to aid with the belief that Earth was growing in mass, in 1888, Russian engineer Ivan Yarkovsky suggested that some sort of ether is being absorbed within Earth and transformed into new chemical elements, forcing celestial bodies to expand. The belief that ether was the reason Earth's growing in mass was so strong, the 2 theses of Hilgenberg in 1933 and 1974, and the thesis of Nikola Tesla in 1935 were all based on the absorption and transformation of ether energy into normal matter. Comic artist Neil Adams had a bit of a different approach. He proposed that positron particles, a form of antimatter, appear continuously inside Earth's globe and combine with other particles while releasing gamma rays. Adams says it also forms new matter. Unfortunately for Adams, modern scientists are confident that no new matter is formed in any of these reactions. During the last few decades, no new evidence has emerged in support of an addition of new mass to Earth. If our mass really had increased, we'd see the effects of it on the orbits of objects in our solar system. The Moon, being the closest object to Earth in space, would be the easiest to test. If our mass had increased, the Moon's orbit would be pulled closer to the Earth, but that's not the case. In 1938, Paul Dirac suggested that the universal gravitational constant had decreased in the billions of years of its existence. This led Pascual Jordan to a modification of the theory of general relativity and to propose in 1964 that all planets slowly expand. Contrary to the previous 2 explanations, this form was, at least within the framework of physics, considered as a viable hypothesis. although measurements of a possible variation of the gravitational constant showed an upper limit for a relative change of 5 times 10 to the negative 12 per year, excluding Jordan's idea. So while there was tons of research underway with the expanding Earth hypothesis, it never developed a plausible and verifiable mechanism of action. So what happened? During the 1960s, the theory of plate tectonics became the accepted explanation in the earth sciences, and the expanding Earth hypothesis was officially rejected in the 1970s after recognition of plate tectonics.
Number 2. A static universe. Also referred to as stationary or infinite, a static universe is a cosmological model where the universe is both spatially infinite and temporarily infinite. Space is neither expanding nor contracting. In the 4th century BC, the Greek philosopher Aristotle established a geocentric universe, in which the fixed spherical Earth is at the center, surrounded by concentric celestial spheres of planets and stars. Although he believed the universe to be finite in size, he stressed that it exists, unchanged and static throughout eternity. In the 13th century, Maimonides suggests that the universe is expanding, and that there are 10 dimensions. In 1584, a static infinite universe was first proposed by Giordano Bruno. Bruno proposed 2 important philosophical dialogues in which he argued against the planetary spheres. Bruno's infinite universe was filled with a substance, an ether, that offered no resistance to the heavenly bodies. In 1687, the static or Newtonian universe was proposed by Sir Isaac Newton in his Principia. His Principia, among other things, described a static, steady, and infinite universe. Einstein, in the early 20th century, agreed with this notion. In 1917, Einstein applied his theory of general relativity in the universe and suggested a model of homogeneous, static, and spatially curved universe. However, this interpretation has one major problem. If gravitation was the only active force, his universe would collapse. In 1929, Edwin Hubble demonstrated the linear redshift distance relation. He observed that spectral lines emitted by stars in the galaxies do not have the same wavelengths as found in the lab. They seem to be shifted to longer wavelengths, towards the red end of the spectrum. These redshifts occur because the galaxies are moving away from our own galaxy, and this shows the expansion of the universe. In April 1931, in a report to the Parisian Academy of Sciences, Einstein finally adopted a model of an expanding universe. In 1932, he teamed up with the Dutch theoretical physicist and astronomer Willem de Sitter to propose an eternally expanding universe, which became the cosmological model generally accepted until the middle of the 1990s. In order for a static infinite universe model to be viable, it must explain 3 things. First, it must explain the intergalactic redshift. Then, it must explain the cosmic microwave background radiation, and third, it must have a mechanism to recreate hydrogen, because in the absence of such a mechanism, the universe would become nothing but black holes. In 1950, Fred Hoyle coined the phrase Big Bang for the creation of the universe, although many people believed he actually intended it as a scornful description of a theory of which he did not himself accept.
Number 1. The Flat Earth Theory. What is it, when, and who debunked it, and some modern misconceptions. The Flat Earth Theory is the theory that the Earth is shaped as a large disk, and in many cultures, it was believed that the Earth was also surrounded by an infinite ocean. Of course, each culture put their own spin on things, such as the Vikings, believing there was a giant snake in this ocean, who was so large that he could wrap around the Earth and grasp his own tail. So when did the Flat Earth Theory fall out of favor? The Greeks subscribed to the theory until the Classical period, or the 5th through 4th centuries BC, the Near East, or the Middle East, and Mesopotamia, until the Hellenistic period, about 323 BC through 31 BC, India, until the Gupta period, or 320 through 550 CE, and China surprisingly believed in the flat Earth all the way up until the 17th century. So who debunked it? The earliest known teachings of a spherical Earth with antipodes, meaning those who dwell on the opposite side of the Earth, can be traced back to Pythagoras in the 6th century BC. The idea, however, didn't catch on until much later, when Aristotle noticed that there were stars that could be seen in Egypt, but not in more northern regions. He also noted that the Earth could not be super large, or the effect wouldn't have been noticeable. This led to Eratosthenes finding the circumference of the Earth and proving that the Earth was spherical. So what kind of modern misconceptions are there? Well, the major misconception about the flat Earth theory is that it was the prevalent view through the Middle Ages. However, the spherical Earth theory was widely accepted among all major medieval scholars, and even among almost all Christian scholars. The spherical Earth theory was the accepted theory from the 3rd century BC onward in the West. An example of the misconception of the flat Earth theory is with Columbus. The common thought is that Columbus set sail around the world to prove that it wasn't flat. However, this was already common knowledge at this point. The true reason he set sail was because he miscalculated the circumference of the Earth, and he thought it would be faster to reach Asia going west. Had he not luckily stumbled upon North America, his ship would have run out of supplies and likely would not have successfully completed the journey back to Europe.
Do 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 do.